Hello class, welcome to lesson 3.2, data collection and sampling methods. So in this lesson, we're going to talk about the various sampling techniques and how some of them can lead to bias versus ones that are more appropriate to statistical analysis. So we're going to talk about convenience sampling and how that can lead to bias. We're going to talk about voluntary response sampling and how that can also lead to bias. We're going to explain how random sampling is used to avoid bias and determine which sampling technique was used. So hopefully by the end of this lesson, you'll be able to understand these four things. So the first type of sampling is convenience sampling. Now it's basically what it sounds like. It's convenient. It's a sample that is done conveniently for the observer, right? Or for the person that's doing the study. So recall that one of the main purposes of statistics is to use information from a sample to draw conclusions about an entire population. So again, and I kind of did this in the other lesson, but if you have a population that you want to study, so let's say this is my population of individuals, and let's say I want to know the average height, right? I don't know what the average height is for the entire population, but I could. But I could take a sample, right? And in this sample, I would get an average height of, say, I don't know, 5.8 feet, something like that. Let's just say. So on average, it's below 6 feet, so on average, 5.8 feet. How does that compare to the entire population? Is the entire population also have an average of 5.8? Or is it greater than, is there less than this value? Or how close is this to the actual population, right? And the idea is that we can't necessarily do it for everyone because we don't have enough, there's too many people or too many individuals in the population to be able to do this for. But we want to see if we can use this to estimate what it would be for the population. Okay, and this is known as inferential statistics. We want to infer what the value of the population is from the sample. All right, so that's the main idea, and this is why. We need to take samples, and we need to know how to take appropriate samples because there are some samples that are more appropriate than others, right? To be able to represent the population. So one way to draw a sample would be to ask, say, the first 30 people, or in this case, the first 30 students, we see about how much homework they work on each evening. So if we're doing a study on homework or something, and that would be known as convenience sampling. So as the students come in, I can, as I see them, I pull them for my sample, right? And that's very convenient for me as the researcher, right? Just pull the first 30 people out, and this is why it's called convenience sampling. Now, notice that convenience sampling involves choosing individuals who are easy to reach, convenient for you, right? So, although this is convenient, it doesn't necessarily mean that it's a good method of sampling. Because remember, the idea is that you want a sample that is representative of your population. And if you conveniently choose those that are easy to reach, then that leaves out some of the variety in the individuals who may not be as easy to reach, right? You want everyone to have representation, an equal chance of representation, and you eliminate that when you do a convenience sample. So students who hang out in the library might actually spend more time doing homework than other students, which leads to a predictable overestimation or underestimation. So if you're doing a sample on how much homework they work on each evening, and you're in the library and you ask the first 30 students there, well, that's convenient to just look at the first 30 students that you see in the library. But keep in mind that those students that actually are in the library, or maybe they might get there first, will actually do more homework on average because of this phenomenon known as bias, right? You're conveniently choosing a sample and therefore it's biasing your results. So your estimation might be that they on average do an hour of homework, right? Whereas the entire population might not be doing that much, right? So there's a lot of things to consider here. So this over underestimation and underestimation is known as bias, right? So if you're taking a sample that is not representative of the population, then you run into this issue where you're constantly missing, right? So in this case, let's say that this represents the population target, right? So let's say that the bullseye is the population mean. So like the average, let's say the average homework time, right? This is for the actual, right? So this is the actual. So I'm going to put this in parentheses. This is the actual for the entire student body population. Let's say it's an hour of homework or 30 minutes of homework on average, right? That they work on. But we don't know what that is, right? We don't actually know what that is without surveying every single person. Now, if you do a sample that is not representative, let's take a look at our population. So we have our entirety of our population. We have our students that let's say this is our students that maybe do not study. Okay, maybe the course is too easy for them. So these are students that don't study, right? So not studying. And then these are kids that do minimal study. And then these are kids that study a lot, right? So now, most of the kids that are studying a lot are probably going to be, in a setting that is conducive to that, say a library or whatever. So if you go to a library and then you sample the students, then you're going to be sampling most of these guys. You're not going to be really sampling the rest. And therefore, this is not representative, right? And that's not what we want, because that's going to lead to bias. So every time you do this, you're going to miss the target every time, and you're going to consistently miss the target. And that is because you're sampling the wrong thing. See this blue portion? That blue portion might be the students that study a lot, right? But you have these other portions that you want to take into account. So that is known as bias, consistently missing your target, essentially. So consistent error in estimation, usually the result of poor sampling technique or design. So let's look at an example. So a farmer brings a juice company many crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. Explain why this sampling method is biased. Is the proportion of damaged oranges in the sample likely greater than or less than the proportion of all oranges in the crate that are damaged? And so the idea here is that this is known as, this is convenience sampling, right? You're conveniently just looking at the ones that are easy to access. So this is convenience sampling. As we are taking the 10 oranges that are easy to access. So we're doing the ones on top, and that's easier to access. Now, that there may be issues with that, right? There's going to be a bias, because if you have, say, a pile of oranges, you might think that most of the good ones are going to be on top. So let's just assume that maybe the good ones are on top, and then the not so good ones might be on the bottom, right? Maybe they were purposely done that way, because when you have a pile, you want generally the easier to access ones to be the good ones, right? Generally speaking, we can make that assumption. Or maybe the ones on the bottom are the ones that are being crushed under the weight of the ones on top, right? So either way, there's you can explain it in any way, like that, but we can see that the proportion of damaged oranges is going to be less than if we sample the ones on the top, right? So let me do this one as a potential bad one. The percentage of ones that are bad are going to be less if we sample from the top than they would be if we had just mixed them up, right? So the proportion of damaged oranges is likely greater, or less, sorry, likely less than the true proportion, right? Than the true proportion. And I'm just going to say the true proportion, meaning the proportion of all oranges, right? They're actually more bad, but we said that there's a little bit bad, right? And that's because we have our bias. All right, so the next type of sampling is the voluntary response sample, and it's basically how it sounds like. You're taking volunteers to respond to your study. So one way that is often used is with an invitation. So you do a general invitation for others to take a poll, express their opinions, etc. And that's known as a voluntary response sampling. You see this a lot. Maybe you're on a website and they ask you to take a poll. Well, that's a voluntary response sample. You may reject, you may not do that sample. You may have people that want to do that study, right? So you have this voluntary nature to it, in which you have volunteers, people that volunteer to take the poll, express their opinions, and those that express their opinions and take the poll are a certain type of people. And what I mean by that, I mean people that like to voice their opinions are generally the ones that take those polls, right? And so there's a general nature of bias there. In addition, you're not really sampling every single person. You're doing only the people that are on the internet, right? And so that also introduces some bias as well. So you want to be careful when you're using voluntary response sampling. So voluntary response sample consists of people who choose to be in the sample by responding to a general invitation. Voluntary response, or they're sometimes called self-selected samples. So again, these responses tend to be non-representative because only those who are willing to voice their opinion tend to participate. So let's look at an example. So the athletic department at El Dorado Community College wants to learn more about the physical fitness of students at the school, including the number of push-ups that students can perform. To obtain their sample, the athletic department sets up a booth in the center of campus with a sign that says, "Free physical fitness testing." Explain why this sample method is biased. Is the mean number of push-ups for the members of their sample likely to be greater or less than the mean number of push-ups for the entire student body? So the idea here is that this is, well, we're putting up a sign, so this is like a general invitation, right? This is a general invitation to come and do some free physical fitness testing. Show us the number of push-ups that you can do, etc. Right? So this is going to be biased because this is voluntary. People have to volunteer for this, right? They're not randomly chosen to do this. So that means that, well, probably you're going to see those people that are really physically fit, and so they want to test their physical fitness. So we could probably infer that there's going to be people that are more physically fit that have a higher chance of wanting to volunteer for this study. And that means you're going to leave out the students that are not physically fit, right? Because who wants to do a physical fitness test when you're not fit, right? So therefore, we're going to say that the mean number of push-ups is likely to be greater than it would be otherwise if had we done it randomly, right? So so this is a voluntary response sample. Students respond to an invitation, right? So they may decline, they may accept the invitation for the study, but the idea is that you're not getting a representative sample. So they respond to an invitation. And what I'm going to say is because, so we'll put this here. So because the students who are more physically fit, or we'll just say that students who are more athletic, we can say that, who are more athletic, will tend to volunteer, or we'll say will tend to accept the invitation, right? Will tend to accept the invitation this will lead to bias. In this case, we're gonna calculate that the mean is actually greater than it should be. So then the mean number of push-ups would be greater than the true number of push-ups for the student body. Okay, so the mean's going to be greater. It might be 5. It might be the mean will be 10 push-ups because these guys are really physically fit. But when you do it for the entire population, and not everyone's athletic, so there's going to be variety in this, right? So it might be actually less. It might be 5 push-ups on average. Who knows? Okay, so now we're going to take the same question and we're going to see how can we avoid the bias that was, present in the example that we just looked at. Okay, and so how can we avoid the bias present in the previous example? Well, to avoid the bias, we want to eliminate this whole volunteer thing. We don't want people to volunteer, and we don't want to do a convenience sample, right? So we want something to be random. So what we can do is, instead of recruiting volunteers, we can get a list of all the students and then just choose some of the students, right, randomly. Okay, so we could do a list here. So let me write this down. Okay. We just look at this real quick. All right, so we can say that we can get a list of all the students. So let's say you got the entire list of students, and randomly select 100 of those students, right? Or 50 of those students, or however many students you want, and randomly select a portion of those students for the study. Okay, so that's how you can truly make it random. Like, if you're doing this as an experiment to interpret the results statistically, you'd have to introduce an element of randomness. Okay, so speaking of random samples, so now we're going to go into this element of randomness, right? How do we do random samples? How do we randomly select those individuals? We know that we need to make it random, but how can we make it random? Well, recall that convenience and voluntary are known as non-random samples because they lead to this bias issue, right? Where individuals are chosen not based, individuals in the population don't have an equal chance of being selected. You might people that arrive early or are conveniently close to you have a higher chance of being selected, and we don't want that. That eliminates diversity in the sample, which means that you're not taking into account multiple people, and that's the point of trying to estimate the population, is that there's a variety of individuals in the population, whether they're human or animal, whatever you're trying to study, or inanimate objects, anything. There's a variety of characteristics that you want to take into account. Okay, so what we want to do is because there's this bias, right? What we want to do is we want to randomize stuff. So to avoid it is to do something called random sampling, which means that everyone has an equal chance of being selected in the process. So easy ways to do this, right? Lottery method, hat method, You're pulling from you. Everyone's name is on a slip of paper. Each name is on a slip of paper. You put those slips of paper on a hat, and then you randomly draw a name, right? And you do this like 10 times until, or however many times until you choose, 10, 15, 20 people from the population. So there are various ways that you can randomize this, right? We can use chance devices. So the idea is that it involves chance. So the first random sampling technique is known as simple random sampling. Okay, so this is where, pretty much what we were saying earlier, a lottery method, a raffle, drawing a card. There's a bunch of chance devices that you can use in order to select individuals from a population. So that everyone has an equal chance, right? So simple random size, the sample, is a sample chosen in such a way that every group of however many individuals has an equal chance of being selected. So if I have 20 individuals, then each individual has a 1 in 20 chance of being selected, right? It's not because I'm close to you and you're the researcher that now I have a half a chance of being selected because I'm close to you as opposed to someone that is far away, right? I'm either close to you or I'm far away. That's two possibilities. If I'm close to you, that's going to be a really high chance. So it's probably going to be, 70, 80%, right? Or maybe 100% because I'm close to you. You're going to choose me for your study, right? Either way, the chances are not the same for someone that is convenient as opposed to someone that's inconvenient, right? And that's not what we want. We want it to be completely random. Now, SRS can be done with technology such as RNG, random number generator. So technology, computers, calculators can do this. Websites, you just go on the website and there's a random number generator. Basically the idea is that everyone has a number and you can choose the number that corresponds to that individual randomly. So there's a couple ways that you could do this. You could do this with replacement and without replacement. So with replacement means that you're putting the card back in the deck, so to speak. So you select the card. So let's say this is your deck. And let's say this deck is not a typical, card deck, right? It's a deck of 100 cards, right? Where each card has a number, right? 1 to 100. And you use these cards to select individuals, right? From a list of 100 people. So you shuffle this deck and then you select a card. So then if you select a card, say you select card 1, and then you put the card back in the deck, right? Like somewhere in the middle of the deck, I guess you could say, that's going to be selecting with replacement. So that person could be selected again, right? And so the idea is that if you're there, there's two ways to do it. You can replace the individual back in there, or you can just hold on to it and not replace it, okay? And that does change the chances of someone else being selected, right? So if you put this individual back in the deck, well, now everyone has an equal chance of being selected again, right? 1 out of 100. Whereas if you did not put the individual back in the deck, well, then now people have a slightly higher chance of being selected, 1 in 99 chance, right? So they have a slightly higher chance. So just something to keep in mind that these probabilities exist, these things exist, and they do influence the chances of being selected. But it could be done either or. If the population is high enough, then it doesn't matter whether you replace it or not because it's very negligible, the change in chance. So the next type of sampling is systematic sampling. So another technique is if you were to select every 7th individual that comes into the assembly line, for instance, rather than conveniently choosing everyone that is, rather than conveniently choosing like the first 100 cans that come in an assembly line, you're only choosing every 7th. So therefore, and this number is random, right? You can change this number, right? But you have to keep it consistent. So if I did every 5th can, then it has to be every 5th can for that sample, right? I can't just change it to every 6th can now. But at least that number can vary, right? So in systematic sample, that number K can change depending on your study. So one person might do every 3rd member, one person might do every 5th member, but you want to keep that consistent when you're doing this systematic sample. So how do we do this with a bunch of individuals? So if you have like 2,000 individuals and you only need 50 of them, then you're going to only you're going to choose every 40th member. And so 40 is going to be your K, right? 2,000 divided by 50, right? And you only need 50 people. So every 40th person, you should be fine choosing that. And so what you do is you give every person a number from 1 to 2,000, and then you randomly choose. So let's say we put this in a deck. I'm just going to say this is a deck, right? Not a very good deck, but you get the idea. So let's say this is randomly shuffled. So maybe this is 103. And then, and so on. So maybe the top number is 103. So I select that card, and that card is 103. And so that person gets chosen from the list of 2,000. And then you're so what you're going to do, so you choose that number, and then you choose every 40th person after that, right? So 40 plus 103 is 143, right? So now 143 gets chosen. And then after that, 183 gets chosen, and so on. And you keep doing this until you have 50 people. Of course, if you're too far in your list, you're going to circle back to maybe individual 1, 2, 3, 4, 5, right? Before the 100, then that's fine. That's fine. You just want to do every 40th thing in the list, in the order list. All right, so that's how you do systematic sampling. The other one is stratified. So stratified is you have a means to divide a population into groups, and it has to be logical groups. It can't just be random characteristics that maybe, you know what I mean? So it has to make sense in the population. So in this case, if you're studying students, it makes sense to divide them into freshman, sophomore, junior, and senior, right? So that's very conducive to that sort of group setting, right? To the groups in the population. And then what you do is if you select a certain portion from each of these groups, that's known as stratified. Now, keep in mind that it still has to be random. All of these are random techniques. So stratified sample obtained. You divide the population into groups, and then you select from each group a certain amount of people. Okay, so for instance, let's say you had these are the students, right, in the school. This is the population, and so you have 4 groups, right? We said we had freshmen, we had sophomore, we had juniors, and then we had seniors, right? So we have 4 groups of students, and so what we do is we take a small portion of each. And so we take 5 freshmen, 5 sophomore, 5 juniors, 5 seniors, and we do this randomly, right? I randomly choose 5 people. So there's still an element of randomness to this study. The other way that you could do it is if you have the groups, instead of sampling from all of the groups, you can sample from some of the groups, right? So again, if you have, 4 groups, we'll say this is group 1, group 2, group 3, and group 4, then you're going to randomly choose maybe a couple groups. Okay, so I draw from a deck, and let's say I draw group 1 or group 2, and I draw group 3. And so I only use those groups, right? Because I drew them randomly. So now group 2 and group 3 get chosen. And so I do not choose from these guys, right? I only choose from group 2 and group 3. And then I select everyone. So everyone gets selected from group 2, and everyone gets selected from group 3. That's known as cluster sampling. All right, and this only works for certain things, right? So if you're trying to study the state of California, then you can do this for counties, right? You can select a few counties from an ordered list, a list of numbers, right? And you can randomly generate the numbers and then choose those counties and then select everyone in those counties, right? So this works for certain populations. So that's the main idea. And the reason why they're called clusters is because when you choose that group, that's one cluster and you take everyone in that cluster. All right, so here's a picture of how this looks like. This is the random. So we're using a random number generator or a random table of numbers and just randomly selecting those numbers and then using that to choose the cars. These might be identifying numbers for the cars, whatever numbers you want to use for the car, and then make sure you pick them out randomly. And then systematic, you're choosing every third, or in this case, every third bottle. Stratified, you have our bunch of groups. So we have men and women. That's a logical grouping system. And then you randomly choose some men, right? So four people from each group. So randomly choose 4 men, randomly choose 4 women. And then that's stratified. And then cluster is you're not choosing all of the groups, right? You're only choosing some of the groups, and you're choosing everyone in those groups. Okay. All right, so state which sampling method was used. Out of 10 hospitals in a municipality, a researcher selects one and collects records for a 24-hour period. So you can think of the hospitals as groups, right? So we have groups of people. We have hospital 1, hospital 2, right? Hospital 3. So think of that as your groups. You have groups of people in those, you have a bunch of people in those hospitals. So that's like your groups. And then you're only selecting one of those hospitals randomly. So let's say I choose hospital 2 randomly. And then you select everyone there, right? Select everyone there. And so that is a cluster sampling. So that's cluster sampling. So this is cluster. And then the second one, we're dividing a group of students according to gender, major field, low, average, height, grade point, average. So these are groups. And then you randomly select 6 students from each group. So you're selecting from every single group that's stratified, right? So every single group is being selected, but only some of the people are being selected in each group. And then subscribers to a magazine are numbered. The sample of these people is selected using random numbers. So subscribers to a magazine, they each have a number, and then you can randomly generate the number. So that's simple random sampling. And then every 10th bottle of Super Duper Cola is selected, and the amount of liquid in the bottle is measured. So every 10th bottle, that's systematic. All right, that is it, guys. Those are the sampling techniques, and how some of them lead to bias, some of them do not. So these 4 that we just mentioned are random sampling techniques, and therefore they eliminate the idea of bias. The first 2 that we discussed, convenience and then the voluntary response, those lead to bias and are not generally good for studies because of this idea of not representing the population. Thank you, guys. Hope you learned something, and as usual, I'll see you in the next one.